Welcome Algebra 2. This is Lesson 92, Boat in the River problem, so eloquently named by Saxon. These are the type of questions that are going to involve our distance charts, rate time distance charts, and take it one step further because we now have multiple variables. Okay, so we have some illustrations up here at the top we're going to talk about first. When we are on a boat and we are going on, let's say, a river, there is a current to that river. In other words, the river itself has a certain rate at which it is flowing. So if you're on a boat and you're going the same direction as that current, that means the current and the boat are both going the same direction. The result of that is that you're going to have the boat plus the current for your rate. But if you're on a boat and you're going the opposite direction of the current, in other words, upstream, then you are actually taking that boat rate and subtracting the current rate from it. So if you've ever been in a canoe, a rowboat of any type, you'll recognize when you're going upstream, it is much harder to push that boat that direction than it is to just let it go with the current downstream. All right, so now we're going to scoot down here and look at star 1. Christy and Emma could go 60 miles downstream in the same time it took them to go 20 miles upstream. If the speed of their boat was 8 miles per hour in still water, what was the speed of the current and what were their times? Okay, so the first thing we need to do is kind of figure out what our chart is going to be labeled with. So we're going to get in the habit of making this first little tab over here downstream, and the one at the bottom is going to be called upstream. Okay, and I am going to put in here, every time we set this up, I'm going to put B plus C, which stands for the boat rate plus the current of the river rate. And the upstream is when you're fighting against it, so it's B minus C. Now I'm going to go back and pull information specific to this question. When Christy and Emma go downstream, they can go 60 miles. That is a distance. So we put that over here on the distance tab. And then for the upstream, the distance they can go is only 20 miles. Okay? And it says it takes them the same amount of time for each of those travels. So I'm going to put a variable in time, t, and it's going to be the same whether it's downstream or upstream. The only other information that we're given is the 8 miles per hour. So we have to read and find out what that is. The speed of their boat was 8 miles per hour in still water. So I am going to be able to change my B value, the boat, and change that to 8, just to give me one less variable to deal with. All right, now that I've pulled all the information down into the chart, I'm going to take that and write two equations, a system of equations, based off of the charts. The first row, 8 plus C times T equals 60, and the second row, 8 minus C times T equals 20. Then you need to go back and distribute the T across each side of parentheses. Okay, so I'm going to rewrite that as 8T plus CT equals 60. And then 8T minus CT equals 20. All right, we aren't used to seeing the two variables. So what I want to look for is I want to be able to cancel out when I have two variables next to each other. That's what I'm going to look for. So if I can cancel out when the two variables are next to each other, I'll be narrowed down to just one variable. And they are already set up for me to do elimination. I can just add straight down. Okay, so I'm going to add 8T plus 8T is 16T. The middle section will cancel, and that equals 80. And then if I divide both sides by 16, I get T equals 5. Okay, so I'm going to go back and look at what that means in the context of this problem. The T in this problem is the time for each of them, since they shared the same time downstream or upstream. So that is going to be written in hours because it was miles per hour that was given for our rate. Okay, so there's my first answer to take care of what was their time. Then it asked for me still to find the speed of the current. Well, that is variable c. So I need to go back to, I'm going to take this equation right here, 8t plus ct equals 60, and I'm going to plug in my t value now that we know that it is 5. So I have 8 times 5 plus c times 5 equals 60. So 40 plus 5c equals 60. Then we subtract the 40 over. 5c equals 20, and therefore c equals 4. This is the current rate, the rate of the current. So I'm going to make that miles per hour. And those are my two answers that I need. Okay? The time and the current. All right. We're going to head over here to question 2. Same type of question. This time it is the water in the Caloosahatchee River. It flows at 5 kilometers per hour. Wyatt can cruise in his boat at 15 kilometers upstream, and the same time it takes him to go 25 kilometers downstream. How fast is Wyatt cruising in his boat in still water? Okay, we're going to start off with that same concept of downstream going first and upstream going second. And remember that downstream is the boat rate plus the current. Upstream is the boat rate minus the current. Then I'm going to take a look at what information we have from this problem. Wyatt is cruising at 15 kilometers upstream, so my distance upstream is 15. That same time it takes him to go 25 kilometers downstream, so I know 25 goes in my distance. I also know it was the same time for both. So once again, we put a T on both of those. Now the information that's given this time is the current. Okay, the water is traveling at 5 kilometers per hour. So I'm just going to get rid of my C here and make a note that it's 5 for that value. Okay, now I have my chart all set up. I can go to writing my equations. The first equation, I have b plus 5. That will get multiplied by t. So that equal to 25. Then I have b minus 5 multiplied by t. So that's equal to 15. Okay, my next step is to distribute the t across both of those. So I have bt plus 5t equals 25. bt minus 5t equals 15. And you may recall that I had mentioned last time we want the two variable part to be the part that we are eliminating. Okay, we don't want to eliminate the single variable, we want to eliminate the double variable, which means that I need to rewrite one of these as a negative. So I'll go ahead and take that first one, bring it down, and rewrite it as a negative equation. So negative bt minus 5t equals negative 25. Okay, so I just rewrote that one. Now it's ready for elimination. My bt's will cancel. I have negative 10t equals negative 10. Therefore, t equals 1. Okay, in the context of this problem, that's the time. And since we are mentioning kilometers per hour, that means my time is 1 hour. So there's one of my solutions. Next thing I need to find is the boat, the B, the rate of the boat. So I can go back to any of these equations that I've written. I'm going to take BT plus 5T equals 25, and I'm going to plug in my T value as 1. So I plug in 1, go back and simplify. So I have 1b plus 5 equals 25. Subtract the 5 over, and I have b equals 20, and the unit that was given was kilometers per hour, kph. There's my other solution. All right, so that's it for the star problems. Now we're going to go to the actual practice questions out of your book. So you'll want to turn to page 384 from your book to read these questions. Page 384 down at the bottom. Question A. Annie and Patrice could go 50 miles downstream in the same time it took them to go 30 miles upstream. If the speed of their boat was 4 miles per hour in still water, what was the speed of the current and what were their times? Okay, so we're going to start off with the same thought of downstream versus upstream. When we go downstream, we go with the current. When we go upstream, we go against it, so it's a minus. And then we go back to find information. They can go 50 miles downstream, so that's my distance for down. In the same time, it took them to go 30 miles upstream. That's my distance for up. It was the same amount of time for both, so I labeled those both T. And then we are given the rate of the boat. The speed of the boat is 4 miles per hour. So for the B values, I'm going to just change that over to 4. And now I'm ready to start my equations. Okay, so my system of equations start off with 4 plus C multiplied by T equals 50. 4 minus C multiplied by T equals 30. All right, and then I'm going to distribute the T across both. So I have 4 times T plus CT equals 50. 4 times T minus CT equals 30. Remember that we want to look for the double variable to cancel out. And fortunately, this one is already set up for that scenario. So I can go ahead and do elimination. Okay, and then 4t plus 4t is 8t. 50 and 30 make 80. If I divide both sides by 8, I get t equals 10 hours. Okay, so that is one of my solutions, that it does take 10 hours. Then I need to go back and find the one variable I have not found yet, which is the C, the current, the rate of the water. So I'm going to start with this equation that I have written halfway down here. 4t plus CT equals 50. And then I plug in 10 for my t value. Go back and simplify that. So 4 times 10 is 40 plus 10c equals 50. Subtract the 40 over, and it looks like my current is just 1. This was in miles per hour for my rate given in the book. So my current is traveling at 1 mile per hour. All right, that is question A. Moving over to question B. From page 384, the sloop Zolly could go 33 miles downstream in 3 hours, but required 4 hours to go 12 miles upstream. What was the speed of the boat in still water? What was the speed of the current? This one is going to be a little different when we start plugging stuff in, but we're going to start the same way every time. We start off with downstream and upstream. We have our boat plus current and our boat minus current. Then I go back and find that it's 33 miles downstream. That's again my distance. And 12 miles upstream, my distance. What's different on this one is the times are not going to be the same. Okay, so listening to this again, 33 miles downstream in 3 hours. but it required the 4 hours to go 12 miles upstream. All right, so there are my time values, and I don't have my boat rate or my current rate. So what I see here is all I have. Okay, now I'm going to write the equations based off of the chart. So boat plus current gets multiplied by 3 to equal 33. Boat minus current, gets multiplied by 4 to equal 12. All right, so I can go back now and distribute the 3 across that. 3b plus 3c equals 33. And then I have 4b minus 4c equals 12. Now, it does not have any double variables that I need to be focused on. I just have a single b or a single c. So I can eliminate either one of those, but right now nothing is set up for elimination. I'm going to have to alter my equations in order to eliminate. So if I were to find a number that both 3 and 4 go into, that would be 12. That would mean the top equation needs to multiply by 4, the bottom equation needs to multiply by 3. And that way we will eliminate a variable such as c there in the middle. So I'm going to rewrite those equations now that I've multiplied. The top one multiplies by 4, and I get 12b plus 12c equals 132. Then I go to the second equation, I'm multiplying it by 3. I get 12b minus 12c equals 36. Okay, I'm ready to add those together. Notice those middle ones should cancel. 12b plus 12b, that's 24b. 132 plus 36, that is 168. 24b equals 168. I divide 24 on both sides, and I'm going to get b equals 7. When I go back and check my unit, it is miles per hour for that rate. Okay, so I now have the boat rate figured out, but I need to go back and find the current. So I could technically use any of the equations I've already written. I think I'm going to go with one of my first ones that I did here, 3b plus 3c equals 33. And I'm going to plug in my boat value as 7. And then multiply that. So I have 21 plus 3c equals 33. And then I subtract that. I get 3c equals 12. Divide both sides by 3. And I get c equals 4. Unit is still miles per hour. So that is the rate of the current. Okay, so that's it for the practice questions. We're going to scoot on over to the homework section. There are 3 charts that we're going to work through, which is to your advantage because I think there's only 3 other questions after that. Okay, so this is homework found on page 385 in your textbook. We're going to start with question 1. Alonzo and Rupert could go 70 miles downstream in the same time it took them to go 30 miles upstream. If the speed of their boat was 10 miles per hour in still water, what was the speed of the current and what was their times? So start with the way we've been doing all of these. We have the downstream versus the upstream. We have boat plus current, boat minus current. Okay, then we check the question to see what kind of miles were provided and the distances that were provided. Downstream was 70 and upstream is 30, and it is the same time, so t value for both of those. Then we check what number did they give besides that, and it says the boat the speed of the boat was 10 miles per hour in still water. So I'm going to just cancel out my B value and put a 10 instead. Okay, and then I'm ready to write my system of equations. I have 10 plus C, put that in parentheses, times the T, equals 70. And then I also have 10 minus C times T equals 30. Go back and distribute the T across both of those. So 10T plus CT equals 70. 10T minus CT equals 30. This one is set up already where the double variables are going to eliminate. So I can just add straight down, eliminate those terms, and I get 20T equals 100. And then from here I divide both sides by 20. T equals 5. The unit we're dealing with is hours. So the time it took each of them was 5 hours. Then I come back to see the only thing I don't have is the rate of the current, my C value. So I'm going to take my equation there from the middle, see if I can go back and solve for C. I have to plug in my T value is equal to 5. So I plug that in. So now I have 10 times 5, that's 50, plus 5C equals 70. Subtract the 50 over. I get 5C equals 20. Divide by 5, and I get C equals 4. That's going to be in miles per hour for the rate. Okay, there's my two solutions for question 1. Let's go over to question 2. The motorboat Alexis could go 60 miles downstream in 4 hours, but required 5 hours to go 55 miles upstream. What was the speed of the boat in still water? What was the speed of the current? So I'm going to start off with, this is my downstream, this is my upstream. Downstream was 60 miles, and it took 4 hours. Upstream is 55 miles, and it took 5 hours. Then I have my boat plus the current when I go downstream, boat minus the current when I go upstream. So the B and the C are the two variables I'll be solving for. Let's write that system of equations now that I have my chart done. B plus C gets multiplied by 4 to set equal to 60. Also B minus C gets multiplied by 5 to set equal to 55. Now go back and distribute and simplify. So 4B plus 4C equals 60. 5B minus 5C equals 55. I'm going to need to go back and multiply each of those equations in order to set up for an elimination. Okay, so the top equation is going to have to multiply by 5. The bottom equation is going to need to multiply by 4. So I'm going to go back and do that now. Distribute the 5 across that top equation. I get 20B plus 20C equals 300. The second equation, let's distribute a 4 across. We get 20B minus 20C equals 220. Set it up for elimination. The middle terms will cancel, and I get 40B equals 520. Divide both sides by 40, and I'm going to get B equals 13 miles per hour. All right. Then I have to go back and find the current. So I'm going to use the equation 4B plus 4C equals 60. Plug in my B value is actually 13. Four times 13, that is 52. If I subtract 52 from each side, I get 4c equals 8, divide by 4, and I get c equals 2 miles per hour. So the current rate is 2 miles per hour. All right, and our last one, question 3. The water in the Kern River flows at 7 kilometers per hour. A speedboat can go 21 kilometers upstream in the same time it takes to go 35 kilometers downstream. How fast can the boat go in still water? So we have our downstream and our upstream. Boat plus current, boat minus current. And it can go 21 kilometers upstream, so that's in the up. 35 kilometers downstream in the same amounts of time, so those are both t. And then the other number that's given is 7 kilometers per hour. That's describing the river, so that is your current that we're going to cross out the c and instead put 7. All right, now that I have my chart filled out, I can write my system of equations. B plus 7 gets multiplied by t, that equals 35. B minus 7 multiplied by t, that equals 21. I'm going to distribute the t across both equations. I have bt plus 7t equals 35, bt minus 7t equals 21. You might be tempted to just go ahead and do elimination. It cancels out your t. That is not going to help you. We have to cancel out the double letter part of our equation, which means that we need to rewrite one of them as a negative. So I'm going to take that top one and rewrite it negative bt minus 7t equals negative 30. Okay, so I just rewrote that one. And now I'm going to go ahead and do my elimination. Now that I know the bt is going to cancel, and I have minus 14t equals negative 9. Let's see, I do that right. Oh, I wrote something down wrong. That's why. This should be a 35, not a 30. So let me just fix that real fast. Sorry for the confusion. And that would mean that when we subtract, we would get a negative 14. That's much better. Divide both sides by the negative 14, and I get t equals 1. Okay, so that is 1 hour. And I don't know that it actually asks for that part of it. It does ask us for the rate of the boat. So I need to go back and plug in to find out the b value. So let's go back to this equation, making sure I wrote it down correctly this time. And my time is 1 hour, so my t value, I can plug in a 1. Nice and easy. So I get b plus 7 equals 35. I just subtract the 7, and I have a pretty fast boat here. It is going 28 kilometers per hour. And that's the final part for question 3. All right, so looking at this page, you only have 3 more questions that you'll have for your homework, and good luck.